Tomorrow is a big day for us in Algebra 1. It is your test day on Wednesday. And so I want to try to do everything that I can to make sure that you're ready for that. And we are going to do a test review like we typically do. It's just going to be this one day. And I'm going to have to break it up into two segments just as a heads up. And the reason for that is, as you can tell behind me, and I want you, by the way, first of all, get your test out if you haven't already. Okay, get your test out. And we're going to go through it, but we're going to do it in a different way. Okay, and I don't mind if you guys want to write what I'm about to tell you on your test itself or in your notes. Either way is fine. The only thing is this. We're going to do it a little bit differently. We're not going to work through a single problem on this test. And the reason for that is, with these videos being recorded, you could go right, I'm not saying you would, but you could go right back and just watch the video, okay, while you're taking the test and just write down all the work and the answers. And so I don't want that to happen, obviously, and I'm not there to supervise to make sure that it doesn't occur. I thought about deleting it, the video, after we did it, but then I thought, well, you could still have your notes that you could use, and while I watch that in class, I can't watch that in your individual houses. So we're not going to do that. However, to your advantage, again, you get to use all your notes, no book, but you get to use all your notes. You get to use your quizzes, so make sure that you have your quizzes done and graded and corrections done, because they'll help you tremendously on the test. And again, on the test itself, you are welcome to write down any of this that we're going to be covering today. You can write it down in your notes and copy that from your notes to your test. I don't care. That's fine. That's fair game. But again, it's going to be a little different the way we do the review, and that will be the reason why. And so now that you have your test out, let's take a look at it together. Obviously, test 10, the one that's not done. Let's look at test 10, number 1. All right, number 1, multiple choice for 1 through 3. And list all correct answers. Guys, if you want, feel free. I feel like these first two are pretty challenging. There's not a lot on our quizzes that are really in line with this. And so I'm just fine if you want to write down, even on your test itself, there will be 2 answers to number 1. Okay, you might go ahead and jot down, there will be 3 answers to number 2. On number 1, there will be 2 answers. On number 2, there will be 3 answers. Okay, so number 1, I'm going to help you kind of get started a little bit, because there's a lot of different stuff that we've covered, and I don't want it to get all jumbled and confused and not come out clearly on the test. So I want to help you just to nudge you in the right direction. And on number 1, which of the following is a perfect square? Which of the following is a perfect square? And what you do for this one, like on A, is you'll look at the last number, or the last term I should say, which typically, and in this case, they all are going to be numbers. Always doesn't have to be though. But these are all numbers. Look at the third term on 1A, and you see 9. What number, first of all, is there a number that when you square it, it gets you to 9? Yeah, obviously so. Okay, what number is that? That's 3. Well, now look at the middle term. If you add those 2 factors of 3 and 3, 3 squared obviously is 3 times 3. If you add 3 and 3 together, does it give you that middle term as the number itself, positive 6? Okay, and I'm not going to answer it for you, but you answer that question. And then also I want you to look at this. The second way of testing whether something is a perfect square is you look at the exponent of the first term, which in this case 1a is a squared, x squared. And if you take the square root of that exponent, which means you divide that first exponent by 2, 2 divided by 2, does it also give you the exponent of the second term? Meaning, is it x to the first power? You answer that. And if you have 2 factors that when multiplied, a number by itself gets you that third term, and when added together gets you the middle term, and then for the first term, if you can take the square roots of that exponent, in other words, in this case, it's 2 divided by 2, and remember, when you take the square root of an exponent, you always divide by 2. Does it get you the exponent of the middle term, or x to the first power? And if those things check out, then yes, it is a perfect square. There are 2 of them that will check out by that procedure that I gave you, and there are 2 of them that will not. Make sure that you write the 2 that do check out in the blank. Okay, number 2. Which of the following is a difference of squares? Which of the following is a difference of squares? Now the first thing is you want to make sure that the numbers themselves in front of the variables, both variables in each problem on number 2, that they are squared numbers, or meaning you can take an even square root of them. And don't get fooled on A, there's an imaginary 1 that's in front of each of those variables. And so the first question you need to ask yourself is, can I take the square root of both of those numbers, like in 2A? Can I take the square root of 1 and get a whole number? Can I take the square root of 1 for negative s to the 4th and get a whole number? Okay, and if so, then it passed the first test. The second question I need to ask myself is this: can I take the square root of all of the exponents in that problem and come up with an even exponent? For instance, on 2a, s to the 6th power, can I take the square root of the exponent 6, which means I divide it by 2, and still end up with a whole number? And for the second one, can I take the square root of s to the 4th, which means I would divide 4 by 2 and end up with a whole number? Okay, and if those check out, each of those, then you do have a correct answer, and you would put that in the blank. And here's a hint for you, okay, really helpful hint on number 2. If any of the exponents, if you're dealing with a potential difference of squares, if any of the exponents on number 2 are not even before you take the square root of them, then it's not going to work. And there's only one of those that does not work, so 3 of them will be written in the blank on number 2. All right, number 3, I figured you would appreciate this, Micaiah and Andelin. 1, 2, 4, 5. I didn't miss 3. You're probably all distraught now. No, that was intentional. Number 3 is so easy, guys. Find the greatest common factor of 12 x to the 3rd y and 21 x squared y squared. And so the first thing you have to do is ask yourself, is there a number that these 2 terms have in common? And then move on to what variables and to the greatest degree. What do the variables have in common, the greatest degree being to the largest of the common exponents between the 2. Okay, not the largest exponent that either one has, but the largest that the 2 of them have in common. So number 3, you know how to work that. I didn't even put anything up there. Numbers 4 and 5. Numbers 4 and 5. Keep your eyes on your test so that you're following me and picking up what I'm putting down. You're just going to factor the common monomial, which means you're going to pull out the greatest common factor between those 3 terms. And guys, all 3 terms have to have in common whatever you put outside the parentheses. And then on the inside of the parentheses, you're going to divide that greatest common factor into, or if you prefer, you're going to divide your first term by the greatest common factor to give you a term here, a term here, a term there. Same thing on 5. What do those 3 terms, the original 3 terms, have in common? You're going to put that out here as a greatest common factor, and you're going to have 3 terms, one right here, and one right here. And those signs, by the way, are correct. And that's really not giving you much, because that's the signs with which you start. You're not pulling out negative terms, and therefore the signs, all of them are going to stay the same. Greatest common factor for each one on the outside, term, term, term. And for number 5, same thing. Greatest common factor on the outside, term, term, and term. Okay, let's move on to numbers 6 and 7. On numbers 6 and 7, you're going to be factoring the difference of squares. And guys, this is really easy, factoring the difference of squares. On number 6, okay, on number 6, as well as on number 7, you're going to end up with 2 parentheses. And because it's the difference of squares, pull out your notes if you don't have them handy yet and consult them. For the difference of squares, when you factor, you're going to end up with 2 parentheses. Alright, and here's what's going to go in each parentheses. On number 6, for the number right here, I should say the term. For the term right here and for the term right there, they're going to be exactly the same. You're going to take the square root of 36y squared. So this term and that term, you take the square root of 36y squared. You take the square root of 36, meaning what times itself gets you to 36, and you take the square root of y squared, which means for an exponent, you divide that exponent by 2. Now that's not the case with numbers, that's the case with variables with exponents. So that term's going to go there and there, and for your second one, you're going to take the square root of 1. And the square root of 1, whatever that answer is, goes right here and right here. Remember the rule of the difference of square. The terms are going to be identical in the 2 parentheses in the difference of a square. It's just that the sign is going to be different in the middle, one from the other, and that's all. Okay, you're going to do exactly the same thing for number 7. Take the square root of 25v to the 6th power. That's going to go there, and that's going to go there. Then you're going to take the square root of 9w squared. Goes there, and it goes, there. And the reason for that, guys, the reason for that is that when you have the difference of a square, as your formula tells you, that means you have the conjugate, which is exactly the same thing in parentheses side by side, but again, the only difference is the sign in the middle. Okay, on numbers 8 and 9, you will be factoring the perfect square trinomials. Okay, factor the perfect square trinomials. And when you get done on these, you're only going to have 1 parentheses with 2 terms. Okay, 1 parentheses with 2 terms. The only thing is, it's going to be squared on the outside, which means you actually have that same parentheses right beside it being multiplied again. It's just that's a simplified way of writing it. And so very similar to the difference of squares, when you're dealing with perfect square trinomials, to find out what goes right here on number 8, just take the square root of c squared. Okay, take the square root of c squared. Which when you do that with a variable that has an exponent, then that means you just divide the exponent by 2 and keep the base, the variable itself. Alright, that's the first term that's going to go there. The second term is going to, in your parentheses for your answer, is going to be the third term in your original equation, and it's just the square root of the third term. So for right here, what's the square root of 9? And then you write that in. And the difference between that and number 9, you can see again, is just a sign. And the reason there's a difference in sign between numbers 8 and 9 is because in number 8, the middle term's a negative. And therefore, there needs to be a negative sign in the middle of this square. Number 9, the middle term is a positive, and therefore there needs to be a positive sign. And that's the only reason for the difference in sign. So in number 9, very similarly, take the square root using the same rules that we've described through this chapter and that I've been very gracious in giving you helpful hints on. I do want you to be refreshed for it, but I'm not going to tell you any answers. You have to find these for yourself. I just want to help get you started in the right direction. For number 9, the first term, take the square root of 4y squared. Take the square root of 4y squared. And that's your first term. Your second term is the square root of the third term in your original problem, z squared. So for the second term in your answer, take the square root of z squared. And that's going to be your solution. Okay, numbers 10 through 13. 10 through 13. They're very much alike, although as I have set off down here, 12 and 13 are just slightly different than the other two. On number 10, because in the first term, there is no coefficient or number that's greater than 1, and it is only 1, what you're going to do is just look at the third term, which is positive 33. Okay, the third term, just look at it, which is positive 33. And you need to ask yourself, what are two factors that when multiplied together give me the coefficient or the number of the middle term, which is 14? What two factors are there of the third term, 33, that when added together give me positive 14? And when I find what those are, I'm going to have as a solution x and x, because it starts with x squared, okay? So x and x, and then whatever those two factors are, whether positive or negative, and keep those signs, whether they are positive or negative integers, those are going to go, the two factors of positive 33 that when added together give you positive 14, one's going to go right there, and the other one's going to go right there. And so you're either going to have x plus or minus something in one parentheses times x plus or minus something. Those two factors of positive 33 that when added together give you positive 14. Okay, 11 operates exactly the same way, except use those signs. It's a negative 18 that when added together give you positive 7. Now, numbers 12 and 13, they're just a little bit different, and as I've stated, they are indeed slightly unique. What you do, you have nothing common that you can pull out of either one from the three terms, first of all. So second of all, what you're going to do on number 12 is multiply the coefficient of the first term times the last term. In other words, 2 times 3, which is 6. And then look at your middle integer, your middle term. And it does have an integer, but it also has a variable. So your middle term is negative 1, the 1 being understood. What two factors of positive 6 that when added together give you negative 1? Okay? Now, whenever you find what that is, this one's different in that you're not just going to write, in the case of 12, a plus or minus a number times a plus or minus a number. Look back at your notes if you need to, and I'm not going to write it up here on the board. Okay, that would be too much of a hint. But look back at your notes, and when you have a number greater than 1 in the first term, you end up writing those factors not in parentheses just yet, but you end up writing a 4-term polynomial, keeping your first term. The two factors are going to be your two middle terms, and you're going to keep your last term, 3. So you're going to have 2a squared, either plus or minus some number a, plus or minus some number a, plus 3. Does that ring a bell? And if not, look back at your notes. That's why we've gone through all this stuff, so that we can learn it, and also you've taken good notes so that you can go back and refresh your mind if and when you need it. And from that point, when you have 4 terms, then you'll put parentheses around 2 sets of binomials, meaning 2 different sets of 2, and then you factor out of each one what's in common. You'll end up getting the same thing in the 2 separate parentheses, and you'll only use that in one of the parentheses for your answer. The 2 common binomials that you've taken out of those 4 terms, okay, you're only going to use them once. And I know this doesn't make a lot of sense just saying it, but if you're looking at your notes, it does. It makes perfect sense. And if it doesn't make sense, you need to look at your notes, because then it will make sense. And you're going to use one of those, and then what's left outside of those 2 parentheses that were factored out go in the second parentheses together. All right, so that's 12 and that's 13. And those are very, very helpful hints and pieces of advice if you'll take and use them. And again, guys, I don't mind. Please, by all means, pause the video if you want. If you haven't done this already, if you need to, go back and look at the video again. Even while all you're taking the test if you want, I don't care. These aren't the answers, but they're going to help you in what's new information to us and a little bit of a challenging chapter to get you on the right track to come up with the right answers. You can use all your homework, you can use all of your notes. Okay, I'm going to erase what's on the board and we will go through numbers 14 through 25 together, and then I'll let you be for the day. Back in the saddle. If you're having any trouble with numbers 12 and 13, I know those are a little trickier. Pay really close attention to what I'm going to tell you in numbers 14 and 15 because they're going to help you. Okay, with our eyeballs on 14 and 15 on page 2 of our test. Number 14 says, as well as same instructions for 15, we need to factor by grouping. Okay, factor by grouping. Now, 14 is super easy. It's basically already done for you. What I was saying in 12 and 13, you can see a little more clearly on 14. Whenever you have gotten to a certain point in factoring, and this is basically taking you to the very last step in a problem that was already done, what you do when you have the same thing in 2 parentheses on 14, 3y plus 1, and then you also have 3y plus 1, only use one of those, but that is one of your answers right there. So, but only use one of those 2 because notice they're either being added or subtracted from each other, but you're going to end up multiplying it, and that's why the rule proves true. Now, what you're going to put in the other parentheses, so one of the parentheses, guys, is going to be what's duplicated in parentheses already, but only use one of those 3y plus 1s for either one of these in half of your answer. The other half of your answer is going to come from what's outside of the 2 parentheses. I'm not going to tell you what that is, but what's outside of those 2 parentheses. And then put that in the other parentheses. And again, the order of them really doesn't matter. What's important is the terms inside the parentheses stay together, and the terms outside the parentheses, all in one parentheses, also stay together. Okay, so your 3y plus 1 is going to go, say, in this one. I'm not going to tell you the other one, but the other one, that information that's outside, you're going to move to the inside of a parentheses in the other side. Okay, on number 15, what do I do like on numbers 12 and 13, okay, and 15 is going to help for that. What do I do whenever I'm trying to find 2 factors of the first and the last terms, and we would have started with the 3-term polynomial here, but I've gotten to the point where I have a couple of terms in the middle. Okay, I have a couple of terms in the middle, and 15 is a little bit different because these 2 terms in the middle aren't exactly the same variable like 12 and 13 will be. On 12, your 2 middle terms are both going to have a base of a, and on 13, your 2 middle terms are both going to have a base of n. So this one's a little bit different in that respect. However, there's a concept of it which is the same, and that's why I'm relating it. When you have 4 terms, how do you finish factoring completely, okay, and solve? Well, remember, just group 2 of those terms together. And ask yourself, what is in common between 8x to the 3rd and negative 6x squared? Factor that out and then put in parentheses what both these terms are when you divide that greatest common factor into those 2 terms. Same thing here. What's in common between 4x and minus 3? I do want to give you a hint on this one, and I believe we did 1 or 2 in our practice problems and our lessons with it. But really there's nothing significant that you can factor out. But you can still always, if there's nothing that's really that important between the 2, you can always still bring out, like in this, a positive 1. Okay? And then just put a plus 1 out here, and then just rewrite 4x minus 3. Okay? But the point is this, when you factor out whatever's in common from this set of binomials, and then from what's in common in this set of binomials, and look at your notes for reminders if you need any refreshers of how to do that, you should end up, when it's all said and done, with the same thing in both parentheses. And then when you rewrite your answer, okay, you're going to use what's common it's just the same thing in those two parentheses. Only use one of those parentheses for your answer, for your first one, your first half. And then for your other half, whatever you factored out that was in common in this one, and whatever you factored out that's on the outside of the parentheses in this one, those are the two terms that go as your second set of binomials in your second set of parentheses. Okay? Number 16. All right, number 16. All I'm going to say about number 16 is it's unique from numbers 16 through 22. That's all I'm going to say about it. It's unique. Read the instructions and look through it, and I think that'll make more sense. Number 17. Number 17. What I want to do is on number 17 through 22, I want to show you, and again, feel free to write it down in your test. I want to show you what your final answer is going to look like, but I'm not going to give you any idea as to what those final terms are. You're going to need to find those on your own. Number 17, you're going to be able to factor out a greatest common factor that's on the outside of a single set of parentheses, and then that set of parentheses is going to be squared. Okay, so you have a greatest common factor, two terms inside the parentheses, and whatever's inside that parentheses is going to be squared. On number 18, you're just going to have two sets of binomials. Okay, that's all it is, just two sets of binomials. And for number 19, you're going to have a greatest common factor that you can pull out before you even start the problem. And then you're going to have three terms. Term here, plus or minus the second term, plus or minus the third term. You're not going to be able to take that problem any further than just taking out a greatest common factor. But make sure that you simplify and divide that greatest common factor into each of those original three terms. Number 20, you will be able to pull out a greatest common factor, and when it's all said and done, you're going to have one term plus or minus a second term in parentheses, and that term or that set of parentheses will be squared. Number 21, you will pull out a greatest common factor. Okay, a greatest common factor, and then you will have two sets of binomials. Term here plus or minus a term there in parentheses, and then times another set of parentheses, term here plus or minus another term. We are on number 22, and on number 22, there's no greatest common factor to pull out in the beginning, but whenever it's all said and done, you will have three sets of binomials multiplied to each other. Term here plus or minus term there, term here plus or minus term there, term here plus or minus the term there. Then on number 23, this is simpler than what it looks. Don't get discouraged when you read it. The formula for the surface area of a cone can be stated S equals 1/2 times C times R plus 1/2 times C times L. Rewrite this formula by factoring the right side of the equation. In other words, you don't do anything with the S standing for the surface area. Just keep that exactly as is, but have S equals. You will be able to pull out a number as a greatest common factor. What are those two terms on the right side of the equal sign? What number do those two terms have in common? You pull that out. They're both also going to have a variable in common. So it's going to be as your greatest common factor a number and a variable. Divide that into both of those original terms, and with what does that leave you? On the inside, you will just have a single variable plus or minus a single variable. Okay, that's once again a very strong hint for that one. Number 24 is both difficult and extremely easy, but not in the same way. What I've done on number 24 with the four squares, I've just helped you to arrange that into a problem that make more sense to you. And all it is you have your x squared, you add the 6x and the 4x together. Okay, so it's x squared plus 6x plus 4x, which is obviously 10x, plus the only other one that's a part of it's 24. Okay, and so what you're doing there is then asking yourself that third term, what are two factors what are two factors of 24 that when added together give me positive 10? And you're going to have a variable to the first power right here, a variable to the first power right there, and then what goes in the second spot of both binomials is each of those factors of positive 24 that when added together give you positive 10. So your answer in the end is going to, again, be two sets of parentheses with a variable, a single exponent, variable, single exponent, plus or minus the two numbers that are the factors of 24. Okay, number 25. Given x plus y in parentheses is a factor, factor x cubed plus y cubed. I really helped you on this one. And you know how the last question, whether it's a quiz or a test, it often really tries to throw you for a loop and just to challenge and see how much of a brainiac you really are. You guys are brainiacs. You can do this. But I do want to help you out here. What you're doing is, remember when we did the long division in our last chapter? You're going to divide the factor x plus y into x to the third plus y to the third. The only thing is, there needs to be 0 placeholders, and let me read it to you to make sure you have it set up right. X plus y, and you're going to divide that into, the first term is x to the third power, or x cubed, plus the second term, 0, x squared y. That second term is plus 0, x squared y. The third term, also a placeholder, plus 0, xy squared, plus 0, xy squared. And then your last term, which you're originally given, plus y cubed, or plus y to the third power. And so you're going to divide this into all of that. And remember, here's the way to start it off. Just look at the first two terms, even though it involves several others. But just look at the first term here and the first term there. And you ask yourself, by what do I multiply x to get myself to x to the third power? And whatever that is, I write there, and then I multiply that term times this one, and that goes there. And then I multiply that term by this one, and that goes there. And then I do my subtraction, and I just keep doing that till I get down to the very end. Okay? Do that till you get down to the end, and you'll have whatever your answer is right up here. That's your answer to the problem. And I know that's kind of incorporating what we did last chapter back into this one. And guys, I don't care if you use your notes from last chapter. Please, by all means, do to be fresh for that one. So, I feel like for really what wasn't that difficult of a chapter, this, as usual, is a pretty difficult test. And I want you guys to know, I know these are extraordinary circumstances, as I've called them before. And so I'm not going to grade your guys' work extremely harshly. And definitely not as strictly as what I have in the past when we have all this time together and ease and all the questions back and forth. We don't have as much as those conveniences. And so what I do ask is this though, give everything you have, and as I always tell you, when you do, it works out in the end, doesn't it? And it's going to be no different this time and for sure the rest of this month, and possibly, we don't know for sure, but possibly for the rest of the year, but certainly through the end of this month. Just give it everything you have, and I assure you everything will work out. I'll be understanding of the circumstances, and all that I ask is you pour everything into it that you have. Use that brilliant brain that God has given you. Okay, that's all of our test review. Feel free to ask me any questions, guys, leading up to it. Call me, message me, email me, whatever you want to do, and I'll sure help you every way that I can. Okay, so tomorrow, make sure on Wednesday, it's test day, we have no video. So it's just test day, and work really, really hard on that and get that turned into me. Alrighty, thank you guys.